Hello, sorry I can't be there today. I am hoping that I will be able to make it tomorrow and guys will be able to take your Chapter 1 Algebra 2 test. Now, what we're doing today is we're going over the review sheet. So I'm going to start off with doing some examples from each one. So for problems 1 through 8, we'll do a few of these here. Hit a select few, and then we'll move on throughout the rest. So you can skip forward through this if you need, go to a section that you already understand, or if you don't understand, you can go to it too. If there's any that I didn't hit that you specifically wanted to look at, please email me and I will get back to you on those problems. So when we look at inequalities, write the inequality in interval notation. So when we talk about interval notation, there's 4 different sets of symbols that we'll be using. One of them is going to be these 2 brackets, like this here, like these brackets here. Well, not completely like this one. As we'll have a set of brackets like this here, or set of parentheses. Now the set of brackets, this here means equal on both sides. So when we talk about something being equal on both sides, we use brackets. Now the parentheses is going to be our not equals, or equal. So when it has just the less than or greater than, we're going to use parentheses on both sides. If they're both less than on both sides, or both greater than, or we just have greater than or less than, we're going to use the parentheses. If we have less than or equal to or greater than or equal to, we'll use the brackets. Now the other two that we have are kind of a combination of the two, so we have a parenthesis and a bracket, or a bracket and a parenthesis. So we're going to use one of these 4. Now we look at this first one here, number 1. So on the left side, the negative 256 is less than x, so we have a parenthesis on one side. And on the other side, we have less than or equal to, so it means we're going to use a bracket. Now x is, the smallest number is 256, and our biggest number is 100. So we'd have something like this here. Now, let's see here. So really what this could look like is negative 256, comma, 100, bracket, is what our answer should look like this here. And that's it. Now because x is in the middle, in between these two numbers, we have it set up like this here. Because what it's saying is negative 200, so we have at the smallest end, negative 256, the biggest in 100. Parentheses tells me that negative 256 is not included. The bracket tells me 100 is. And that's all we have to do for this one here. Now for number 2, it says x is less than 200. So we're wanting all the numbers smaller than 200. Now the smallest possible number we can have is negative infinity. And the biggest number we can have is 200, because we're talking about all the numbers less than 200. And we'd use parentheses on both sides because, again, when we talked about this in class and we went over this originally, we talked about the infinite hotel. Now we can never actually get to infinity or negative infinity. So we use a parentheses with that, and then comma 200 parentheses because, again, less than is not equal to it. And that's all we have to do for this here. Now number 3 will have a similar case. X is greater than or equal to negative 140 or 174. So the smallest number here is negative 174, and it's included this time because of our equal sign. This here says greater than or equal to. And the biggest number we can have, biggest number would be infinity. And that's it. And we would do the same thing with the rest of these here. So 4 would be parentheses, or bracket 6, comma, 247, bracket. And that's it. Now I'll look at number 8. Now number 8 on the answer key is wrong. It really should be negative infinity, comma, 9, with parentheses around both because it's not equal to. And this here is the same as saying x is less than 9. because these here are the same way to write it. So the answer key had it backwards. It should be this here. Now set builder notation. Set builder notation is going to be written in this kind of form. We'll have a curly bracket X bar and then our description is how most of these are going to be set up for all this here. Now the only way that this will change is if X is an integer then we'll have to change it like number 10. But otherwise, it will remain in that form. So for this here, for number 9, negative 24 to 87, x is less, negative 24 is less than x is less than 87, less than or equal to 87, is our statement here. Because that's what this is describing if we described it as an inequality. The negative 24 is less than x is less than or equal to 87. And that's doesn't look quite nice, so I can type it out. Negative 24 is less than x. And I'd have to come and get my less than or equal to 87 is our inequality statement, or our description of what's going on here. Now to have it be our set builder, so we would have x bar this here, because again, so we don't have to include x is an integer like up here, because here, since it's an interval, we're talking about all real numbers. So here we're saying that here x, for all real numbers x, such that negative 24 is less than x is less than or equal to 87. And that's our answer. And that's all we have to do for this here. Now number 10 is a little bit different because we're going to have x is what? X is an integer, the set of all integers. Okay, so I pause it there for a second to see if I can find it, and they did have this e as an element of the integers. Integers such that x is greater than or equal to 200. Now we could use this again here. There we go. Get rid of that. Now what we could say, instead of integers, is we can have our z, because if you remember back, z with the two bars is another way that we say integer, so we can do it in either one of these here. Both of those count as the same thing. Now here, number 11, the set of all real numbers except 2. So since it's just the set of all real numbers, we can just say our curly bracket x bar, because again, that's saying the set of all real numbers x. Well, here it's saying the set of all real numbers except negative 2. So that means it can be any number that's not equal to 2. And that's all we have to say for this one here. And that's it. So I'll go on and look at 12, because we'll do parentheses x. Well, x is the set of all natural numbers. So we can say x is an element, insert, and it doesn't, I don't think I have those there for natural numbers, and then greater than 56. So x natural number such that x is greater than 56. And that's all we have to do for this one here. Now the one that's going to be a little more complicated is going to probably be 14. Now since it's just two sets of parentheses, we can use that because the one on the right, sorry, not right, the one on the left, parentheses negative infinity comma negative 4 bracket is really telling me that I have x is less than or equal to negative 4 because we're talking about all the numbers that are less than or equal to negative 4. Now the one on the right, 4 to infinity, is talking about all the numbers where x is greater than 4. So we were saying or x is greater than 4. So we have these two statements here. This is our description. Now again, what are we talking about? We're talking about all the values of x, all real numbers x. So since we're talking about all real numbers x, we're going to do our curly bracket x bar to say all real numbers x such that x is less than or equal to negative 4. Let's see. So this side right here, or x is greater than 4, this side here. And that's all we have to do for this one here. So this here solves each system by augmentation by any method. Sorry, I can't read. Solve each system by any method, but you might have to do one by hand. So the one by hand, most likely, if you're taking the paper test, is going to be the bonus. So the bonus question would be the 3 by 3, solving one of these by hand. If there's not a bonus, then you don't have to worry about it. So these here, 16, 15 through 18, you can do by any method. So we can solve it by doing it one variable elimination, eliminate one at a time. Or what we can do is we can do it by using a graphing calculator. We can use a graphing calculator to solve these here. And unfortunately, I don't have the TI-84 graphing software installed on this computer. So if you want to go back over how to do that, you can look at the video for chapter 1.6, I believe, on my YouTube page, or what you can do is you can go to google.com and type in TI-84 plus solving variable systems equations using matrices. So this is another way to find it. So if you go to google.com and do Google search TI-84 plus solving 3 variable systems of equations using matrices, it'll bring up a video. So you can either watch the video I have or this one here, and it'll walk you through exactly how to plug this in. I will also, if you are able to come in early on Tuesday, hopefully I'll be there. I'm planning on being there. You can go on, I will go back through this with you, showing you how to plug these in. And again, when you're plugging them in, one of the main things is that the x's, y's, and z's are all lined up. X's, y's, and z's are all lined up in both when you plug this in. And one of the big reminders is whenever you plug them in, when you get your answer, it'll give it here. If the bottom row is all zeros, then it's all real solutions or infinite many. And if the last zero is a number other, so we have 0, 0, 0, 1, it's no solution. And that's all that we have for that there. So I'm going to move on for those there, because those you can just plug into the calculator and it'll give you your answer. Now for these here, writing the augmented matrix and stating the dimensions. So one of the big things, again, we need to make sure is that the x's, y's, and our number all line up. So 7x, 46x, negative 41y, negative 2y, 29, 19. So they line up. And now we're just taking the number. So negative 7, or 7, negative 41, 29, 46, negative 2, 19. And that's it. And this here is a 2 by 3. So those are our dimensions, 2 by 3. And that's all we have to do for this here. Now let's look at number 20. Now if we look at number 20, the middle row, the middle equation is a little bit not right because it goes y, x, z. So we can rearrange it, or I can just do it by hand because we know that x should come first. So negative 7 should be first. And I'm just going to rearrange it. I'm not going to have to rewrite it out. Y is 1, z is 4, and our number is 15. Now if I wanted to, I could have rearranged this and moved the 7x up front, or rewritten this since down here is negative 7x plus y plus 4z equals 15. I could have written it out that way, then use the magic of technology. And have it this way here. So we can rewrite it pretty easily if we're just doing that. Now there's sometimes we might have to move things from one side to the other by adding it to both sides or subtracting it. But other than that, we just need to make sure that z, y, or x, y, and z order up. So on the top one we have 6 for x. Now since there's not a y, that means the y value is 0. And then we have 4 for z, and our number is 2. And the bottom row would be 6, negative 1, 3, 20. Then the last thing we need to do is dimension, so we have 3 here and 4, so this is a 3 by 4. And that's all we have to do for these here. So it'd be the same for the rest of these. It's just making sure x, y, and z all line up. So x is first, y is second, and z is last on the left side, and then our numbers, anything without variables, is on the right. And that's all we have to do for these here. Graphs. So write the graph g of x, whose graph is a representation of the indicated transformation of the graph f of x. So we're writing the transformations. And again, since most of these here, I will tell you on the test, are going to do at least 2. We're not going to have many that do just 1. So here, a translation of 3 up and a vertical stretch of 2. Now before we really look at this first one here, 25, now there was a list I included at one point that looks like this here. F parentheses x minus h is our left and right, where h is the value of how far we move it to the left or how far we move it to the right. F of x plus k moves it up or down. A times f of x is our vertical stretch or shrink. Our reflection f of negative x is across the y-axis, and negative f of x is across the x-axis. So for across the y-axis, really what we're doing is replacing every x value with negative x. And here, negative x, f of x, we're just changing all the values. So if we had negative 5x, it's now positive 5x. So if the number or sign or the term was positive, it's now negative. And if it's negative, it's now positive when we go across the x-axis. So a translation of 3 units up. So what we're looking at would be the f of x plus k, where the value of k is 3. So really it'd be f of x plus 3 in this case. So we're just adding 3 to the function. So for us, that would mean we'd have 6x squared minus 1 plus our k value, which is 3. Well, our like terms are negative 1 and 3. So 6x squared isn't going to change. Well, negative 1 plus 3 would be plus 2. So we finished our first one. Now a vertical stretch of 2 is our a f of x. F of x. Now we're not focused on this one anymore because we're focused on this one here because we're talking about it translated up 3 and then a vertical stretch of 2. So what we're going to do is we're going to multiply the whole function f of x by 2, or really our 6x squared plus 2 by 2. So we'd have 2 times 6x squared plus 2. So everything in there would multiply by 2. 2 times 6 is 12. X squared, 2 times 2 would give us plus 4. So our new function, which we'll call g of x, or on the test, as long as you have the new one circled or whatever we're having circled, whatever your final function is we'll have 12x squared, 12x squared, there we go, plus 4. And that's it. So really what we want to do is one of these at a time. So here in 26, translated 4 units right and 3 units up. So the first thing we're going to do is the 4 units to the right. So we'd have our f of x minus h. Now the value of h for this here is equal to 4, because since it's to the right 4, it's positive 4. So here we would have f of x minus 4. Now because we don't just have f of x anymore, we have f of x minus 4, we're going to replace this x value with x minus 4. So we have the absolute value of 2 times x minus 4 minus 1. So we'll have to multiply through by 2, so 2 times x is 2x. 2 times negative 4 is negative 8 minus 1. And what that'll give us is, well, the absolute value of 2x minus 9 is our first part of this here. So once we do the first step, we get, moving it to the right 4, we get 2x minus 9. Now the next thing we need to do is do up 3. So we got the first part done. Got this finished. So do up 3, we're going to add 3 to our function here. So I'm going to erase all this here. Erase all this here. Except for our function, because this is our new function now. And what we want to do is we want to take it and move it up 3. So we take this function, I'll still call it f of x. And plus k is because we're moving it up. So our k value is 3. Well, we'll take 2x minus 9 and add the k to it, which is just plus 3. And well, since we can't combine inside the parentheses, that's our final answer. So it's just saying that g of x is equal to 2x minus 9 plus 3. And that's it. That's our answer. And that's all we have to do for this here. Now I'm not going to worry too much about reflections, but that's because they're not going to show up too much on the test. It's mainly going to be doing some of the other transformations. But if we wanted to translate it 3 units up, we would add 3 to it, which would give us 6x plus 2 for our up 3. Now to translate it across the y-axis, we would take f of negative x, so we'd plug negative x in for x. And so we'd plug it in right here. So that would make it negative 6x plus 2 would be our final one, or we can call it g of x, is our negative 6x plus 2. And that's all we'd have to do for that there, because across the y-axis is just changing the value of x from positive to negative. Now, if we're reflecting across the x-axis, we'd make everything negative. Now, we wouldn't go inside the absolute values, we just stay on the outside. So since the outside of the absolute value is positive, across the x-axis it would become negative absolute value of x, 4x minus 3. And since 2 is positive, it becomes negative. And that's the reflection across the x. And if I wanted to translate it up 4, I would just add 4 to it. which we still have negative absolute value. Type this out. So our final function g of x would equal the negative absolute value of 4x minus 3. So we didn't do anything left, right, or reflection across the y. So nothing inside the absolute value changed. And then we'd have plus 2 because negative 2 plus 4 gives us a positive 2. And that's it there. I'm not going to worry about number 29. So if you want to go back through and kind of write those down, it might be helpful, especially when we talk about these here. Now 30 through 33, talking about these here. Perform the indicated operations if possible. So again, the only way we can't add or subtract is if the dimensions aren't the same. So I'm going to skip to 33, because 33 I have a 3 by 3 and a 3 by 2. So this one here, because the dimensions aren't the same, this is not possible. There's no way for us to be able to solve 33. Now the rest of these here are possible. We can do these here. So number 30, what we're doing is we're multiplying each term by 1/4. So 1/4 times 16 is 4. 1/4 times 24 is 6. And 1/4 times 30 is, it'd be 30 over 4 because 30 doesn't go into 4. Or is they both have a common factor of 2. We could say that this is the same as 15 halves. And lastly, we have 9 over 4. So we're just multiplying everything by 1/4. It turned out that 16 and 24 did reduce down to whole numbers. It doesn't always work that way, but this one here, it did. Now you could have also typed this in the graphing calculator. The graphing calculator will do any and all of these. If I wanted to type 31 into the graphing calculator, I would go into the matrix, do second matrix, go over to edit, and edit this first one, 2, 7, 9, 8 is matrix A. Set matrix B as 1, 4, 16, 27, and matrix C as 3, 8, 7, 2. And then when I went to type it in, we can do second matrix. Instead of going over to edit in that first row, I'd hit A, and it'd come down in the home screen, then minus second matrix, and then go down to B, plus, and then do matrix C to get the answer. Or we can do this by hand, so I'll do these first two here. So 2 minus 1 is 1. 7 minus 4 is 3. 9 minus 16 is negative 7. And 8 minus 27 is negative 19. Would be our first matrix. And then we add to it our 3, 8, 7, 2, and that's not a good looking 3. There we go, that's better. And then we'd add these together, so 1 plus 3, so we're adding numbers in the like spots. 3 plus 8 is 11. Negative 7 plus 7 is 0, and negative 19 plus 2 is negative 17. And that's it. That's what we get for this here. That's all we have to do. Now if we have scalars like this one here, number 32, we have to do the scalar multiplication first, and then we can combine. Now we could have also done this in the calculator, setting 314 as A, 867 as B, A, B, C, and typed it in as 2A minus 4B plus C in the calculator, and it would have given us our answer. It would have told us what the answer was. Now if we're going to do this by hand, I'm going to multiply this first one by 2. So 3 times 2 is 6, 1 times 2 is 2, and 2 times 4 is 8. Minus, I'm just going to multiply the second one by 4. I'm not going to worry about negative 4. 4 times 8 is 32. 4 times 6 is 24. And 4 times 7 is 28. Plus, and then we have 3, 3, 3. Now we can do 6 minus 32, which would give us negative 26. 2 minus 24 is negative 22, and 8 minus 28 is negative 20. So we have that there, and then what we're going to do is we're going to add our 3, 3, 3 to it. So negative 26 plus 3 is going to be negative 23. Negative 22 plus 3 is going to be negative 19. And negative 20 plus 3 is going to be negative 17. And that's all we have to do to solve this one here. And the last problem, number 34, is going to be the exact same thing. It's just that we have a 2 by 4 and a 2 by 4 instead. So it'll just be a few more steps. And that's all we have to do for these here. Now that brings us to the last one, write the equation of a line. Now there's two ways that we can have it. We can have it in slope intercept form, which is y equals mx plus b, where y is our intercept, or m is our slope and b is our intercept. Now we have point slope form, which is y minus y1 equals m times x minus x, and I'll do the subnotation again, 1, parentheses. And we have this here. Now again, m is still the slope, but y1, x1 is our point. Now we use the second equation if we don't know what the y-intercept is, or the y-intercept, our value of b. So on 35 here, well, I can see that the y-intercept down here is at 0. So the value of b here is 0. Now the slope, we can use the slope formula, and again, the slope formula is y2 minus y1 over x2 minus x1. So our y12 value I can say is 33. Our x2 value is 100. Now our other point was 0, 0. So it works out our slope here is 33 over 100. So the equation for this here is y equals 33 over 100 x plus 0. But we don't have to include it because adding 0 doesn't change anything. So this here is our equation, and that's all we have to do for this here. Now for 36, we don't really know. It could be that it'll tell us the y-intercept down here, but it's hard to see what it is because we have these little kind of broken lines, these squibble lines, which is telling us the graph is broken, so it's hard to tell exactly what it is. But we are given 2 points. So since we're given 2 points, we can find the slope. So I can do 80 minus 30, because those are our two y values, 80 and 30. Since I used 80 first, 40 has to go first for our x value, so 40 minus 15. So 80 minus 30 is 50. 40 minus 15 is 25. And well, 50 over 25 gives me 2. Now I'm going to use the second formula, y minus y1 equals m, which is 2, times x minus x1. And y1 and x1 is just a point, so I can pick 40 and 80, or 30 and 15. So I'll pick 40 and 80, so 80 goes in the y, 40 goes into the x. So we'll simplify. 2 times x would give us 2x, because we've got to multiply through. 2 times negative 40 is negative 80. And at this point here, we can add 80 to both sides. Because again, we wanted to get it in y equals mx plus b form, so y equals 2x. Well, 80, negative 80 plus 80 cancel, and hey, they cancel over here. So it turns out the y-intercept was 0, but our overall equation is y equals 2x. And that's all we have to do for this here. Now the last one is this one here, speed of the car. Now it tells us that the y-intercept is 65 because it crosses the y-axis at 65. So we have b is equal to 65. This point is really 0, 65. Now I can use my slope formula here. Well, the y value of one point is 65 at this point here, so we have 65 over 0. And this other point here, I have 65 and 2. Well, 65 minus 65 gives me 0 over, would be negative 2. Well, that's just 0, because anything over 0 or 0 over any kind of number is always going to be 0. So our slope is 0. So we have y equals 0x plus 65. Well, I don't have to include the 0x because it doesn't add anything. Anything times 0 is just 0. So what I'm left with is y is equal to 65. Y equals 65. I'll type that out. Is our equation. Now when we look back at it, look back at the graph, since we have a straight line at 65 going straight across, it's not going up, it's not going down. It's just y equals whatever that number is, whatever that y-intercept is, or kind of the y value. Not 65. Sorry, I got that messed up. It's not, I had this completely backwards. Does the y-intercept? Nope, I take that back. I have it all right. The equation is y equals 65. It just turns out that point is not correct. It should be 2 comma 65. I had those numbers flipped. So it's y equals 65. It's just this point here is wrong. So the equation for this here is y is equal to 65 because it's just going straight across. So if we have a line that's going flat, it's not going up, it's not going down, has a slope of 0, it should be y equals that number, whatever the y value is. So here it should have been 65. And that's it, because again, so the next thing is just those. So that's all that we have for this review sheet. So again, if you have any questions on something I didn't go over, one of the problems I didn't go over, please email me. I am planning on being back tomorrow. I will be back tomorrow, so guys, be ready for your test tomorrow. And again, all of your homework is going to be at the end of the day of the test. So since we're taking the test tomorrow, have it all done by midnight tomorrow.